All righty, this should be a pretty quick video. And it's the kind of video that, you don't get these problems right tomorrow. Might have to wonder if you're looking at any of these. Because we're trying to give you the whole period to work, make it a workshop. And if I lecture there, I'm taking away practice time for you. So this on Pythagoras. We're also going to look at the distance between 2 points, just those practices. That's it. Just a little Pythagorean relationship here. I'm going to draw the triangles in standard position. I'm going to attach them to the origin. And this ability to do this quickly and easily, do these computations quickly and easily, is going to help you down the road. It's going to help you learn some trigonometry, where we really look at angles to ratios and ratios to angles. It's not all we do. We look at an angle, we look at the ratios of the one side to another in a triangle. We define those, and the ability to do the Pythagorean theorem quickly, make some computations, do them quickly is going to be very helpful. Also in conic sections, looking at parabolas, circles, ellipses, hyperbolas. It's going to help there to understand what you're looking at. And it's also going to help in a calculus class, really looking at implicit differentiation. You can do that with this relationship. Very helpful. Okay, so let's just look at your classic 3, 4, 5 triangle. All right, and we're pretending we're at the origin here. 3, 4, 5. All right, and I'll make it smaller here because we're really looking at the square areas. That's a pretty small one there. And Pythagorean relationship is the sum of the smaller square areas add up to the bigger square area. So 3 gets us 9 units of area, 4 gets us 16, then 5 gets us 25. And there's 3 computations here. Well, actually, there's 4. Should I say 6? I don't know. There's 9 plus 16 gets you 25. There's 25 minus 16 gets you 9. There's 25 minus 9 that gets you 16. And if you know the area, then you know the side length. The square root of 16 is 4, the square root of 9 is 3, and the square root of 25 is 5. So we should be able to do that quickly and easily pictorially. We want to work with the pictures. I mean, there is a formula here that we'll look at in a while, but formulas come from generalizations, doing a lot of computations and going, I'm doing this to X, I'm doing this to Y. Where eventually you go, well, this is X, this is Y, we'll call that Z. Right? And when we start studying trig, we're going to make our hypotenuse always positive. But depending upon what quadrant we draw these triangles in, X's and Y's are going to take on some negative values. And we got to get used to that as well. But for starters, let's just do 5 quick calculations. Let's look at, let's say that this is 5, and say that this is Y, and I am giving you 10. Okay, and we want to know what the Y value is. I shouldn't have given you that one because we already know it's 5 root 3 from our trigonometry. All right, but let's go see why that's true. All right, so planted a seed there. So what do we have for square area? Well, that's going to be 100. What's the square area for 5? 25. So therefore, boy, that's an ugly drawing because this is going to be a smaller area. Very not drawn to scale. All right. If that's half that, it should have been a 30-degree angle. Anyway, 75 is we're looking for that length, right? So it's the square root of 75, which happens to be the square root of 25 times the square root of 3, and yes, it was 5 root 3. And I've asked you to memorize the square root of 3. I doubt you have yet. If you're anything like the other classes I've taught over the years, unfortunately. Most of you don't know yet that that's 5 times 1.73, but I'll keep mentioning it. And at least you got a sense of size here. All right. Being very sarcastic here today. All right, so let's get a better drawing. Repetition's my friend. Let's call that 4. That's bigger than 4. Let's call that 7. And let's find the length, and I'll make dotted lines now. And let's, again, make this a right triangle. All right, so what do I see? I see 16 units here. I see 49 units there. And so therefore, what do we have for our biggest square area, 65. So therefore, that is the square root of 65. Okay, so we'll do a few more, maybe 2 or 3 more. All right, let's go with right triangle. Oh, I just drew one like that before. Let's have the base be a little longer, the height be a little smaller, and the hypotenuse. And there's our right triangle. And let's make this one 4. Let's make this one, I don't know, what's it look like? How about 11? All right, and we want to know what that x value is. All right, so 11 squared, if you didn't know it's 121, you know it now. 4 squared is 16. So take 16 away from 121. I believe we have 105 units of area here. So what is x? Square root of 105. Let's do another one. I think we've covered all the bases here. Let's just get a little practice in. Let's actually get a where they're the same. Okay, so they're the same. So let's say that this is 6 and that is 6. All right, this is going to become 6 root 2. I wonder how I know that. Let's find out. All right, so 36 and 36 makes 72. We're looking at the square root of 72, which is the square root of 36 times the square root of 2. Oh, so 45-degree angles. I wonder if that's a coincidence. I wonder if this was an 8 and that was an 8. If this would become 8 root 2. I wonder. All right, what else have we got here? We've got one last one. Let's do 1. Let's do 1. Let's do y. Let's do 10. Maybe you can start doing these quickly and come up with the square root of 99. I do believe that's what we have. We have an area of 1, an area of 100. 100 minus 1 is 99 units of area. And we're looking at that side length of a square, which is a square root. All right, so it looks like a Jackson Pollock here. Oh, I had my note here to come back to this. Yes. Now I don't even remember why. Oh, well, I always forget things in the video, but let's do the distance between 2 points. There's 2 points. Wonder what that distance is. Well, I suppose if we look at the change in x and the change in y, we have a method now of finding it. All right, so let's call this 3, 2. Oh, that's an ugly 2. Let's call that 3, 2. Let's call this 7, 9. Let's make it 8. Oh, okay, well, we need the horizontal distance. I believe that horizontal distance is 4 units. You know, you can take some time and pause the video whenever you need to see where that 4 comes from. And it sure looks like 2 to 8 is 6. Well, it looks like I got 16 and 36 units of area, which is 52. 52 is 2 times 26. 2 times 26 is 2 times 2 times 13. It looks like it's 4 times 13. So 16 is 52. And we now know that that's the square root of 4 times 13. So why don't I call it 2 root 13? That's that distance. A little more practice here. Now let's go with a negative y value here. So let's go 2, 5. We'll put that right there. And let's go over to here and down to here. Let's go down to here. Let's say that this is the coordinate 6, 4. Well, I guess we're going that way and that way. All right, and this way is downward. And 2 to 6 is over 4. So it looks like we got 16 units here. And even though that's a negative, height, it's still, when you square it, 1 unit. So it really doesn't matter. What you're really looking for is the distance between 2 and 6, which is 4, the distance between 5 and 4, which is 1. And you're simply squaring, and that's really your distance formula, right? Your distance formula is x2 minus x1 squared plus y2 minus y1 squared, right? And it's good that you know that. Doesn't hurt. But drawing the pictures is the way to do these calculations, right? 16 and 1, Square root of 17 is the distance between those 2 points. One last one. I usually read left to right, even if the coordinates aren't given to me in that fashion, but let's look at from -4 to 5, -4 to 5, excuse me, and let's go over to 2 comma, I don't know, 7, right? So we have a horizontal and a vertical. What's my horizontal? From -4 to 2 is 6. My vertical is 2. So I'll pause the video. You do that out. Hopefully you got 36 plus 4, which is 40. And hopefully you take the square root of 40 and say that's the square root of 4 times the square root of 10. If you say square root of 40 tomorrow, I'm going to give you a check with a circle, which means, yeah, you're right. You haven't said anything wrong. But I hope you learn to restate the square root of 40 as 2 root 10. All right, so there's some quick practice. Hopefully it's enough practice so that when you get those 2 questions tomorrow, you go boom, boom. All right, a little tired here, a little brusque. Just the way it is. See you in class in a couple hours.